other than electrovalent and covalent, the third type of bond is coordinate. This is probably the trickiest one for you right now because electrovalent, covalent, you would have done before. Uh, Coordinate bond, also called dative bond. This is actually a mix of the two of them, so I'm just going to write down here. Coordinate. It's also called the lone pair effect. So at this level, there are only two major examples of this bond which you will study. One is, as I said in the previous section, NH3, which turns to NH4 plus, and the second one is the hydronium ion. You might have heard of it before, as well as the hydroxyl ion. Hydroxyl is OH, hydronium is H3O. So we'll just go over it pretty quickly. NH3, we drew the covalent bond in the previous video, something like this. The single line denotes that only one electron is being shared, contributed. One electron is being contributed by both of the atoms, and there were two over here. We called it the lone pair. Now, when you have this atom and you have an H plus atom, these two combine. H plus, remember, is basically just one proton. It's one proton, one electron, but with the electron ionized. So it's basically one proton looking for two electrons to complete its valence shell. So this is looking for two, and here it's found two. So what happens is this leads to both of these bonding. You already have the N in the middle, the H here, the H here, the H here, and to this you add the ion that combines and gets those two electrons, and this whole thing becomes a positive ion. And this is also denoted as just a simple arrow, right? N underneath, H on top. This is how to represent a coordinate bond between the two elements. This is the ammonium ion, and I'm quickly going to do the hydronium ion as well. Hydronium ion, you might have studied in middle school as well, that it's the ion that causes acids to have acidic properties. Well, hydroxyl ion is the one that causes bases to have basic properties. So I'm just going to draw hydronium first. Hydronium is H3O. Whole thing is a positive. Okay, so this actually originates from a water molecule. Ammonium ion originated from ammonia molecule. So the water molecule covalent bond looks something like this. Single covalent bond between these two over here. And since the electronic configuration of oxygen is 2, 6, it has 6 in its valence shell. That means 1 here, 4 are left. 2 lone pairs, that means. So it looks something like this. Same thing if you add a single proton, that's an ionized hydrogen atom. It takes this form, forms a dative bond, coordinate bond, and it looks something like this. We can use the arrow to show the coordinate bond over here, and of course the H will only take up 2 electrons, so these are taken. This is still a lone pair, still existing despite this bond, and the whole ion takes up positive sign. Um, in OH, it too originates from the water molecule. Um, Again, the hydroxyl ion, it formed something like this. This is the water molecule. In this, actually, water molecule dissociates into two. Over here, what's happening was it's H2O, sorry, H2O plus H plus. In hydroxyl ion, it's H2O disintegrating into H plus as well as OH minus. So this is the water molecule at first, and it dissociates. It gives the hydroxyl ion, which looks something like, you can show the hydrogen electrons as a cross over here, simpler, oxygen as a circle. So that would be 1, 2, 3, 4, 5, and in the middle, another one would come here. Okay, and this is the hydrogen electron. So this is the hydroxyl ion, takes up a negative, and at the same time gives out an H plus. Also, you may be wondering how in the world did that happen. If you look at the water molecule over here, if you break it up, there's actually a cross over here, a circle here, another circle here, another circle here, and a cross here. So it's releasing an H plus ion. That means this one over here is getting released, and it's leaving behind its electron. So it's only a proton and it moves out. So it leaves behind its cross. So in totality, you have this cross over here and you have this cross here. So in this diagram, you have two crosses over here. And the oxygen electrons, you have 1, 2, 3, 4, 5, 6. Here you have 1, 2, 3, 4, 5, 6. So that's how it's formed. This is a hydroxyl ion, and this is the hydrogen um, ion, it's proton. And basically in your syllabus, these are the three that will be tested. You should know these pretty well. And it's a tricky concept at first, but once you get used to it, it's not tough at all. With that, chemical bonding comes to an end, so it's not a tough chapter, but well, yeah, it's pretty scoring as well, so you should do it well.